All right, in this video, we're going to go over graphing exponential functions. So the first thing we need to do is we need to, well, let me pick my color pen first. We need to know what a graphing, what an exponential function is. And this is more like a general equation right here. But the base form is going to be y equals a number times a base raised to an x, which is an exponent. Okay. And when you have something modifying the x, that's when we're going to move to the left or to the right. Right? If it says minus h, that means you're going to the right. And if it says plus h, that means you're going to the left. And this k value is what's going to move you up or down. Up means plus k, down means minus k. But in general, the basic form is going to be this one, y equals a b to the x. The main things that we want to have is we have two types, as we've been discussing in class. We have a growth function. And when is this growth? Well, when a is greater than 0 and when b is greater than 1. Then we have a growth function, right, which is going to look like this. Remember that b is always going to be a positive number other than 1, right? So b cannot be negative, b cannot be 0, and b can't be 1. And we discussed this in class. All right, so this is an example of an exponential function because the exponent is a variable. This is y equals a b to the x. So let's assign the variables. All right, so from here we can see that the 2 is the base because it's the one with the x. So b equals 2. So what is a? Well, a is going to have to be an understood 1 over here that's being multiplied to this base raised to an exponent. So in this case, a equals 1. All right, so if we're going to graph this, we're going to have to pick values. So I pick these values. And what we're going to do is we're going to plug this into the function. So we know that to get y, we have to do 2 raised to the negative 3, which is 1/8, which is 0.125. We have to do 2 raised to the negative 2, which is 1/4, which is 0.25. 2 raised to the minus 1, which is 1/2, which is 0.5. 2 raised to the 0, any number raised to the 0 is 1. Oh, wait, no, not 1. 2 raised to the 1, which is 2. 2 squared, which is 4. And 2 to the 3rd, which is 8. And what we're going to do is we're going to plot this. Now you notice that your x's go from negative 3 all the way to positive 3. So negative 1, negative 2, negative 3. 1, 2, 3. And the y values go from 0.125 all the way up to 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go ahead and plot these points. Negative 3.125, negative 2.25, negative 2.5, 0, 1, 1, 2, 2, 4, and 3, 8. Let's see if I can draw this line. There we go, that's not bad. And this is a growth exponential function. So now let's look at some of the features from our growth exponential function. What is the end behavior? So as x goes to positive infinity, right, as x gets bigger and bigger, You see how the function is going up? That means the function is approaching positive infinity. As x becomes negative, it looks like the function is approaching this value. And that value happens to be a horizontal line at y equals 0. So it's a horizontal asymptote. So as x goes to negative infinity, the function is approaching 0. We have a horizontal asymptote at y equals 0, and for notes purposes, it's always going to happen at this k value. All right, so if you have a modification of k, then that's going to be the horizontal asymptote. Since there's no k here, right? Let me see, Control Z. If there's no k there, then that's why the horizontal asymptote is at y equals 0. Y-intercept, well, this is going through 0, 1. Right, and for purposes, it's going to go through 0, whatever the a value is. And if you'll notice, in our cases, the a value happens to be 1. So that's why it goes through 0, 1. Domain and range. The domain, it seems that whenever x is negative, the function exists, and whenever x is positive, the function exists. So the domain is all reals. But the range, the function only exists when y is positive. In fact, when y is greater than 0. So your range is going to be y is greater than 0. All right, because the function doesn't exist down here. So let's try graphing these functions. So when I look at this, y equals 1/2 3 to the x, the fact that the x is over here tells me it's exponential. So I go and I think about the basic form, y equals a b to the x. That means a equals 1/2 and b equals 3. The fact that b is greater than 1 tells me that it's growth. The fact that a is positive tells me that it's normal growth, right? So the function is going to go like this. My y-intercept is going to happen, my horizontal asymptote, since there's no k value here plus a number, it's going to happen at 0. And I know my y-intercept is going to happen at 0a. A happens to be 1/2, so it's going to be 0, 1/2. Zero, 1/2, and y equals 0. Right? No, what are you doing? And so this is regular growth, so it's going to go like this. Now, yes, we could plot more points, but we're just trying to get the general idea of what this is going to look like. All right, the next one. If you look at this one, this is y equals a b to the x. So a is -1 and b is 1.5 because b is the base. B is the one with the exponent. And the fact that b is greater than 1 tells you that it's growth, but the fact that a is negative tells you that it's reflected. All right, so growth looks like this. Reflected growth looks like this. So our graph is going to look like this below that asymptote. So then we go ahead and we get ready. All right, and then we ask ourselves, where's the asymptote happening? Well, do we have a k value? No, so it's happening at y equals 0. All right, y equals 0. Then we're asking ourselves, where is it crossing? So we know it crosses at 0a. What's the a value? -1. So it's crossing at 0, -1. There's no changes here to the left or to the right or up and down, so we're good. So this is 0, -1. And it's reflected growth. There we go. Best I can do on my tablet. All right, not only do we have growth functions, we also have decay functions. And decay functions are going to look exactly the same. Y equals a b to the x. We'll have something modifying the x, and that means that we'll move to the left or to the right. In this one, we have plus h minus h. And this means that we're going to move up or down. Plus k minus k. This is also the y asymptote, y equals 0, the horizontal asymptote. And the y-intercept. Oh, I gotta go through all the characteristics. I forgot about the slide. All right, it's gonna be decay when b is between 0 and 1. A is still positive. All right, so you have to have these characteristics. And once again, b can't be negative, b can't be 0, and b can't be 1. So let's pick some points to graph. This is an example of a function. So this could be y equals a b to the x, right? With b being 1/2 and a being 1. How do I know that a is 1? Well, it's an understood one, that is 1 times this base raised to the x. So I'm going to pick some values to go ahead and sketch this. I'm going to use the function. So this is 1/2 raised to the -3, 1/2 to the -2, 1/2 to the first, 1/2 squared, 1/2 cubed. All right, so I went ahead and I got all the values, and I went ahead and I sketched the graph. And so now let's talk about the graph. The end behavior, as x becomes positive, as it goes to positive infinity, the function is approaching this line, y equals 0. So the value of the function is approaching 0. As x goes to negative infinity, the value of the function is approaching positive infinity, right? It's going up. We seem to have an asymptote at y equals 0, horizontal. And this is the same as before. This is going to be your k value, always, if you have one. If you don't have one, then it's 0. Your y-intercept in this one is 0, 1. And for all of your exponential functions, it's at 0k. And remember, this gets modified by h, and that gets modified by k. Domain is all reals, because the function exists when x is negative and when x is positive. And your range, the function only exists for positive y's on this one. So y has to be greater than or equal to 0. Right, because the asymptote is 0. All right, let's practice graphing these functions. And we have y equals 1/2 to the third. So we know that this is a, and we know that this is b. And because b is less than 1, this means that this is decay. A is positive, so that means it's normal decay. So it's going to do this, right? There is no k value here plus a number. So it's y equals 0, the asymptote. And 0, comma a happens to be 0, comma 2. Oops. It's supposed to be a straight line. 1, 2. Let me get another color. Right, this is the asymptote. We know it's going to taper off at y equals 0, and it's decay. It's got to go through this point and then approach this asymptote. There we go. The next one, this is a, or a equals -1, and b is 1/2. The fact that it's 1/2 tells you that it's decay. This is between 0 and 1. The fact that a is negative tells you that it's reflected decay. I always think about it. So if decay is going to be this, then reflected decay is going to be this. So my graph is going to look like this under the asymptote. There is no k value, right? So that means y equals 0. And for my intercept, what is the a value? A is -1. And since there is no h and there is no k, this stays like this. Okay, so I'm sketching this. 0, -1. Getting another color. Y equals 0. And it's reflected decay, so it's going to do this. There we go. All right, let's start graphing some that have variations on them. So when I look at this function right here, I see that this is A, this is B right here. I notice that this means that I'm moving to the right 1 unit. And this means that I'm moving down 4. And also that y equals -4. Let me see. B is a 2. So since B is greater than 1, that means it's growth. You see A is positive, so it's regular growth. Right, so the function is going to look like this. And I already know what y is. Y is -4. And 0, comma A is the intercept. What is A? A is a 3, but I'm moving right 1 unit, so +1. And I'm moving down 4 units, so -4. So it's 1, 3 minus 4 is -1. So the actual point that's on the graph is 1, -1. So we're sketching this, and you plot 1, -1. Y equals -4. 1, -1. -2, -3, -4. And it's regular growth. Make it to the point. There we go. That's what it would look like. All right, let's do the next one. So when I look at this, I see that this one is A, this is B. This tells me that it's moving to the left 2 units. This tells me that it's moving up 3 units, but that also y equals 3. The fact that B is 1/2 tells me that it's decay. And the fact that A is positive tells me that it's regular decay or normal decay, which means it's going to look like this, right? Let's see, I already know what the horizontal asymptote is going to be. So I think 0, comma A. What is A? A is 3, but I'm moving to the left 2 units, so -2, and I'm moving up 3, so +3. So this is -2, 6. -2, 1, 2, 3, 4, 5, 6. Okay. The asymptote happens at y equals 3, 1, 2, 3. And it's regular decay, so it's going to be doing something like this. Okay. All right, so please make sure that you review this instructional video and that you work on your practice.